The next part of discussion is function generator. Function generator is a very important lab instrument. Almost all electronic labs do have function generator. What do we do with this function generator? The function generator is used for this thing. It is used for generation of sine wave. It means it can produce a sine wave. It is used for generation of a square wave. It is used for generation of pulses, triangular wave and sawtooth wave. All these waves it can produce. Not only it can produce, but also it can control amplitude, frequency, time, duty cycle, offset, etc. So this function generator is a very important electronic system. We use it for generation of different kinds of mathematical functions like sine, square, pulse, triangular and sawtooth wave, for testing of different electronic instruments or for study of different electronic projects. That is why we have to study the function generator. Internal block diagram of function generator is like this. Initially we have got this resistance kind of thing, which is a external frequency control, then frequency control network. Then here we have a constant current supply or constant current source, CCS1, and here we have CCS2. There are two constant current supply sources. The one is here and the other is here, right? This will produce current and pass this current in this direction. This is positive current, and this number 2 source will take current in this direction. This is negative current. Okay, so there are two current sources here and here. If you look at this diagram, the arrows of the direction of current is also shown. The current which is produced by CCS1 is positive and the current produced by CCS2 is negative. That is why the direction of current is opposing. Then we have got this block, these two things, an operational amplifier coupled with a capacitor in feedback is called an integrator. Okay, this integrator is actually combination of operational amplifier and capacitor in feedback. Output of this integrator is given to the next block, that is voltage comparator, that is typically a multivibrator. Then the same output is also connected to this one, that is resistance diode shipping circuit, and the other branch goes out as it is. There is no block. So the output of integrator has three connections: one to a multivibrator, second goes as it is, and third to a diode shipping network. So after this voltage comparator or a multivibrator, we have got output amplifier, and after this resistor diode shaping also we have got a output amplifier. The output amplifier first gives you a square wave, then the second output of integrator gives you a triangular wave, and third output, which comes from your resistance diode shaping network, gives you a sine wave. This is how your function generator produces three important waves, that is square wave, or sometimes called rectangular wave also. Then we have second waveform as a triangular wave, and third one is your sine wave. Now how it works: this frequency control network has got a knob that helps you change the frequency of any function that is being produced, right? This frequency control can be done internally or externally. So this frequency control network just helps you to change the frequency of the signal that you want to prepare. Now what happens when you turn it on? The frequency control network is connected to CCS1 and CCS2. CCS1 and CCS2 operate. Before we understand, we try to learn how this works. We have to assume something, that is, the charge on this capacitor C is 0. We assume that there is no charge on any of the plate on the capacitor. Okay, there is no charge on capacitor C. So initially the CCS1 turns on, it produces current goes in this direction, it goes to the integrator, it charges the capacitor, and it goes to the multivibrator, or that is voltage comparator. Now what happens there, the capacitor goes on charging, it charges like this. Capacitor goes on charging, it charges like this, right? It charges like this. One time it will cross a threshold. This is your level, this is your choice, your threshold. You will tell the system to stop charging anymore, right? So or if your capacitor charges to peak, then CCS1 will stop and CCS2 will start. The CCS2 starts, then the current flows in opposite direction, so the slope of current is negative. Current flows in this direction, right? So the current on capacitor, or voltage building on capacitor, is of this shape, right? Now this goes to the multivibrator. Multivibrator compares the instantaneous voltage with the threshold voltage. This is your threshold voltage, this one, and this is your instantaneous voltage. So as and when your output is less than threshold, this kind of output you will get. Okay, so on rising edge, this one you will get this edge as long as it is more than your threshold, it will keep flat itself, and as and when this negative slope occurs and this line crosses at this point, the falling edge starts. So your output of multivibrator is of this type. Okay, actually you got this waveform, but because of comparison you got a square wave or rectangular wave. Okay, so the output of integrator goes to the multivibrator. Multivibrator compares the instantaneous voltage on capacitor with the threshold voltage, and it will produce a square wave or rectangular wave. The output amplifier gives you sufficient strength, right? Gives you sufficient strength. So here in output amplifier you can adjust the amplitude of the square wave, and this is how it produces a square wave or a rectangular wave. For triangular wave, CCS1 charges capacitor C and discharges CCS2 discharges the capacitor C. So the simple waveform is triangular, it continues. So if you don't do anything, if you let this waveform go out as it is, you will get a triangular waveform. For sine wave, the CCS1 and CCS2 as usual charges and discharges the capacitor. You will get a triangular wave. This triangular wave is passed through a resistance shaping network, which will shape this waveform in a sine format. So triangular waveform will become a sine wave. We don't have to see much more detail about how this resistance shaping network works, resistance diode shaping network works. So we just say that this particular network converts a triangular wave into a sine wave. This is how your function generator works. The function generator is used for generation of sine wave, a square wave, triangular wave, etc. The basic thing that is there in the function generator is this one, integrator, this capacitor. Okay, and then two more important things, CCS1 and CCS2. The rest of the things are coupled with the concept. Okay, so there is one more block diagram which we can use for explanation of function generator. Same thing, but this is a little complicated than this one, so I recommend this kind of block diagram to be used for writing your answer.